Hi, welcome to my video on graphing the derivative of a parabola, part 2. Graphing y prime, which is the derivative of y. So, y prime is the derivative. The derivative of x squared is 2x. The derivative of negative 4x is negative 4. So, we have the derivative. So, if we let y prime, which is the derivative, equal to 0, the slope of the tangent is 0. So we go 2x minus 4 equals 0. 2x equals 4 divided by 2, x is 2. So if we take the parabola and sub in, that means if you sub in x is 2 in the parabola, you get the point where the vertex at 2, you get the y value 4 minus 8, which is negative 4. So the vertex, when you let y prime equals 0, you're picking a horizontal line whose slope is 0. So that's the x coordinate of the vertex. This is the y coordinate of the vertex, which is negative 4. So if we plot the vertex of 2, negative 4, the vertex is approximately right here. Now, if you take the parabola and draw more parts of it, so what we'll do, we'll take the parabola and we'll factor x outside of x minus 4. And so we let y equals 0, we get the x-intercept. So the x-intercept is when x times x minus 4 equals 0. And that occurs at x is equal to 0. And it also occurs when x is equal to, that's a minus 4, so it's a 4. So that means that when x is 0, y is 0. And when x is 4, y is 0. So that's the x-intercept. So the x-intercepts are the origin 0, 0 and 4, 0. So this is the parabola that, and the reason I'm drawing the parabola that I don't have to, I just want to draw this parabola, and let's see if I can draw it half decent coming in here. Coming in on the other, there should be. Okay, now you say what I draw a parabola for, because the graph of the derivative is y prime equals 2x minus 4. So this is the derivative, and the derivative is a line. So this is a quadratic, degree 2. This is a linear. So the linear is y prime. So I'm going to do the y prime, which is derivative, in a dotted line. So the y-intercept is negative 4, which is here. The slope is 2 over 1. So we rise 2, run 1. We rise 2 and run 1. So this is the derivative, which is a line. So this line is y prime equals 2x minus 4. Now, I have it as a broken line because I want it to be the derivative of this parabola. And as a result, if you, excuse me, if you think about it, I'm going to do this, x and y prime, even though I graphed it like here. So if I take 2, this vertex here, this vertex is 2 and negative 4. So when you're doing the math, if you have a vertex, you drop the perpendicular to here like this, to this line. So this is the point of 2, 0. So this point, any point on this line, whatever value of x you pick, the y coordinate is the slope. So the slope here of this parabola is a 0, which is, we had it here to be horizontal line. So if you put 0 in, this expression, put 0 in, the 2, not put 2 in, 2 is the x coordinate of vertex. So we take the 2 and put the 2 in here, we get a 0. If we put 3 in here, we get 6 minus 4 is 2. Put a 4 in, you get 8 minus 4 is 4. If you put 1 in, 2 minus 4 is negative 2. And you put 0 in, you get a negative 4. Notice you're coming, the slope is 2. What I'm trying to get at here is that all these values of x, this is the slope of, if you take any point, if you take the point, let's take the point, let me illustrate. Let's look at where x is 3 on the parabola. So if x is 3, we get 3 squared minus 4 times 3. That's 9 minus 12 is negative 3. So this is the point on the parabola at 3, negative 3. So this point on the parabola, 3, negative 3, is right here. So this point of 3, negative 3. So if I did the tangent at this point, the tangent at this point will approximately come through like this. So this is the tangent at the point 3, negative 3. So what I'm going to do, I have the tangent drawn, but I'm not going to go down here until, so if I come on down, so I'm down here somewhere. So is it negative 8, negative 7, negative 9, or what? But we have this point. So at 3, so when x is 3, you put 3 in here, you got a 2. So when x is 3 into y prime equals 2x minus 4, you have 6 minus 4 is 2. So when x is 3, the slope of the tangent is 2. So that means that y prime equals mx plus b. So at 3, the point is x comma y, and this is the slope. So the slope of the tangent is 2. So we take negative 3, which is the x coordinate, the y coordinate. The slope is 2. The x coordinate is 3, and we work out the y-intercept. So negative 3, 6 plus b. B is negative 3 minus 6. So b is negative 9. So y prime, which is the equation, slope is 2. Negative 9 is the y-intercept. So that means that at this point right here, 3, negative 3, this tangent is coming down and hitting here at negative 9. So it comes on down and goes through there, like that. So I'm just trying to illustrate. And at 3, this point, 3 is here. 3 on this line gives you the 2. So the 3 gives you the 2, which is this point here. So this y coordinate. So this is 3, 2. Notice that 2 is the slope of this tangent. So on this line, all the y coordinates are the slope of the tangents at a particular point on the parabola. So I just wanted to make sure I have a good explanation on that. So let's try another one, but it won't take so long this time. Graph y prime. So y prime is equal to, derivative is negative 2x minus 2. So we make y prime equal to 0, so negative 2x minus 2 equals 0. So negative 2x equals 2. Divide by negative 2, and we have x equals negative 1. So the derivative of is y prime is negative 2x minus 2. And the slope of the vertex, y prime, when you let y prime equal to 0, the slope of the tangent is 0, and the slope of the tangent is occurring at x equals negative 1, which is the x coordinate of the vertex. So again, when the slope is 0, the value of x is the x coordinate of the vertex. Plugging that back into the main equation of the parabola gives you the vertex, y value of the vertex. Just got to be careful here. Negative 1 squared is 1, so that's a minus 1. Negative 2 times negative 1 is 2, so that's 1. So the vertex is negative 1, 1. So the derivative is here, but I just wanted to drive home a point. The derivative is this. So the derivative, the y-intercept is negative 2 right here. The slope is negative 2 over 1. So that's down 2, right 1. Or we can go up 2, left 1. Up 2, left 1. So I'm going to draw the derivative as a broken line. So this derivative is y prime negative. Now you might say, why did you do y? I wanted to illustrate that the equation of this derivative is in terms of y. When I'm putting a y prime here to say that this line is broken, it's the derivative of this parabola. And this parabola has a vertex of, and again, the vertex of the parabola is x is negative 1, 1. So the vertex of the parabola is right there, and that point is negative 1, comma 1. And I just want to look at again, I keep making sure it's fully explained. So we let y equal 0. So that means negative x squared minus 2x is equal to 0. Negative x outside of x plus 2 equals 0. So x is 0 and x is negative 2. So that means you got x is 0, y is 0, x is negative 2, y is 0. So these are the x-intercepts at 0 and negative 2. So 0 and negative 2 are the x-intercepts. The vertex is negative 1, 1. So this is the parabola that we have, like this. And the derivative is a linear. Again, this is a quadratic. Degree 2. Derivative is a linear. And there's the derivative. So any point on this parabola, no matter what point you pick on this parabola, the y value will be, right here you got a negative 2. So the slope of the tangent at this point will be negative 2. So any point that you pick. And I just want to illustrate, if you take this, the vertex of negative 1, 1. If you draw a line down like that, come down, then this point here has the same coordinate on the vertical line. So that's a negative 1, 0. And what does that mean? It means the x-coordinate of the vertex is dropped down. So this point, on this derivative, on this line, negative 2x minus 2, this point at x is negative 1, the slope of the tangent is 0. Again, if you put negative 1 back in here, you will get a 0 slope. And if you pick this point, which is, this point is 0, negative 2. So if you pick a 0 and put a 0 in here, you get the negative 2. And the negative 2 is the slope of the tangent. Just wanted to explain it, that the derivative of a quadratic, polynomial, quadratic, parabola, the derivative is a linear. So that finishes off. And again, if you like all my videos, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.